Hi, I'm Brian Turner from Roman Manufacturing. Today we will review common reasons why MFDC power supplies fail and test to make sure that the MFDC power supply is functioning correctly. The four most common reasons for MFDC power supply failure are overloading, lack of coolant water, leaking coolant, and double grounding. However, before you think that your power supply has failed, you should conduct two very simple tests to verify that your MFDC is functioning properly. The first test is the diode testing procedure. The second is a standard MFDC function test. Before you start, make sure the power supply is removed from tooling, wiring, and is on a dead circuit. And if in a weld cell, make sure that you're properly locked out. Things you will need to perform this test are a flathead screwdriver, a continuity tester, jumper wire, 22 gauge or larger, a mega ohm meter with leads, and eye protection. Be sure to remove the ground strap before any testing. The test results will not be accurate if the ground strap is left on. Also, be sure to clean off any weld flash and debris from the secondary pads and primary connections. A volt-ohm meter can be used to check diode function. However, the meter can vary greatly depending on the manufacturer. Some meters have the capability to perform diode tests, while some don't. We use the flashlight continuity test method because it is more consistent. The only way to confirm the polarity functionality of the diode is to properly connect the flashlight leads to the power supply. The positive lead goes to the negative pad, the negative lead goes to the positive pad. Turn on your continuity tester. If the light comes on, you know the power supply is functioning in the right direction. If you reverse the leads on the power supply pads and turn on your continuity tester, you should have no light. If the light was to come on, that would indicate that your power supply is not functioning correctly. The second test, we're going to check insulation in between the primary, the secondary, and the case of the power supply. Also making sure that our ground strap is still removed. We're going to connect the jumper wire in between our pads to protect our diodes. The first part of this test, we're going to take our mega ohm meter lead and connect it to either primary lead. We're going to take our second lead and connect it to the secondary pad. We're going to turn our mega ohm meter to the 1000 volt range, and we're going to hold our test button down to allow it to take a reading. This should read near an infinite reading. Next, we're going to take from our secondary to the case of the power supply. And again, we're going to press on our mega ohm meter, allow it to read, and should be near infinite. The last test, we're going to go from our primary, again either lead, to the case of the power supply. Press our test lead, again should read near infinite, and that lets you know that your power supply is functioning properly. If for whatever reason any of the readings are less than 10 mega ohm, you should replace your power supply. If the testing today indicate that the diode and transformer are functioning correctly, it is likely that the welding issue is not the transformer. Be sure to clean off any weld flash and contaminants from the secondary pads of your transformer. On behalf of Roman Manufacturing, thank you for watching.